Hello, and welcome back to the Maths Behind the Economics YouTube channel and the Logarithms for Economics series. This is video 20, and this is the last in the series. In this video, just like in the previous two videos, we will be working on economics themes formulae and we will be applying the log rules to them. Again, I will be explaining which log rule I am using. Let us get started. Question number 1. ln e to the rt. Okay, so what's going on in here? We have got a multiplication behind the log sign because p and e has nothing in between them, so that's always multiplication. So we can break it out as adding the same logs. So this would be ln p plus ln e to the rt. Okay, again, just like in the previous videos, this rt is in the exponent, so we can bring that down as a multiplier. So ln p plus rt ln e. And now ln of e is just equal to 1. So what we ended up here is ln p plus rt. Now here, we need to be clear about whether p, r or t is our variable. But if r or t is a variable, we do end up with a linear expression. So by applying the log rules to this formula, which is exponential in either r or t, we ended up with a linear formula in either r or t. And look, we only needed a couple of steps, so it's worth our effort because the whole expression has become significantly simpler. Right, let's look at number 2. I've got log and then a long bracket, 1 plus r to the 4 over 3.05. Now again, because we have got a fraction in the argument of the log, then we can break this out as a subtraction of those logs. So I can write log bracket open 1 plus r to the 4 minus log 3.05. Right? Next step, again, we have got an exponent in the argument of the first log. So that can be brought down as a multiplier. So I can have 4 log 1 plus r minus log 3.05. Now, in this expression, r is the only variable. Now, we can't really claim that this expression is linear because the variable is behind the log sign. However, because linear functions are so much simpler to deal with than logarithmic or exponential function, what often happens is that this log 1 plus r becomes a variable on its own. So you could kind of name it to y. And then I would end up with the 4y minus log 3.05. You can put that into the calculator and you end up with some number. But I'm just going to call it c now, minus c. So I can still mold this expression into a linear form just by treating the whole log as a separate variable. I hope that kind of makes some sense, and please watch out for this trick in your lectures or practice questions. Number 3, ln 500 e to the minus 0.05 t. Okay, so again, 500 and e has got nothing in between them, so that's a multiplication. So I can rewrite this as ln 500 plus ln e to the minus 0.05 t. And again, just like in all the previous examples, this minus 0.05 t can be brought down as a multiplier. Not forgetting that when we're adding a negative number, we're just going to end up with subtraction. So this can be replaced as ln 500 minus 0.05 t times ln of e. Again, what do we remember about ln of e? That's always equal to 1. So the simplest possible version of this expression is ln 500 minus 0.05 t. And remember, ln 500 is just a number. I'm just going to call it c because it's a constant number. So again, this can be treated as a simple decreasing linear expression. Now we are more than halfway through the practice questions. Let's make a bit more space and move on to question number 4, which is log 2.5 bracket open 1 plus 0.085 over n 5n. Okay, what's going on in here? Well, we have got a multiplication between 2.5 and the bracket, so let's apply that log rule. So we can break this out as log 2.5 plus log 1 plus 0.085 over n to the 5n. Okay, let's move further. Log 2.5 does not change, but what we notice is that there is an exponent in the argument of the log, so that can be brought down as a multiplier. So that will be 5n log 1 plus 0.085 over n. And now I can't really do anything else because what's behind the log sign also has my n. And the n is a multiplier outside. So can I just simply claim that the log expression itself is a constant number because the n is in the argument of the log? So this expression hasn't actually cancelled down to a simple linear formula, but this is still simpler and probably easier to understand than the original, which has both the log and the exponents. And therefore I'm going to leave the expression in this form. Now let's move on to question number 5, which is our last question for this video and for the log series. Isn't that exciting? Log 750 times r times 5. Now, first of all, r times 5 is just basically 5r. So from now on, I'm going to treat it as 5r. And again, there's a multiplication between 750 and e to the 5r. So I can break that into an addition of the same logs. So this is going to be log 750 plus log e to the 5r. Again, I can bring down the 5r from the exponent. So it's going to be log 750 plus 5r log e. And again, depending on whether log is e base or base 10, I will be able to replace this log e either by 1 or some kind of constant number which the calculator will be able to tell you. Regardless, the variable here is r, so again, this formula has been simplified down to a linear expression. Right, this was the last example in the last video that was concentrating on logs. You now know every single log rule, probably more than you have ever imagined existed, and you have seen how to apply them in specific scenarios. So the new series will be on the applications of exponents and logs in economics, and we will be deriving the common exponential and logarithmic formulas used in economics, as well as doing practice questions as always. I hope to see you with the new series. Thank you for watching. Bye.